It's no coincidence that aggregate planning problems almost always involve some kind of table, rows and columns. It's because really that is the easiest way to work with all the different pieces of information that you usually have to deal with in aggregate planning. This particular problem, even though it's really small, is actually a really good example of that. Let's take a look. Maynard Associates has 62 units of a certain product on hand currently. Okay, so that is on hand inventory. The demand forecast for next week is 25 units, so there's that piece of information. And Maynard plans to produce 10 units of that product during the next week, so there's production information. What's the question? What will be the ending inventory for this product next week? I would create a table. Okay, usually on aggregate planning tables, the forecast is at the top. And this table is going to be kind of funny because there'll only be, it's true, one column. It's only talking about one time period in the future. It's just talking about next week, but fine. There's a forecast, right? There's plans for production, so I want a row for that. That's why I'm writing that label. There is also, it's actually asking about inventory, so I had better have a row for that. There's only one column, that's next week, except with inventory, I'm going to create a little strange box to the left of my one column first off, what is all this for? To store this information. To make a note of, this is next week, but it said that right now we actually do have 62 of these. That'd be a perfect place to put that. Okay, now wait, this is to store all the rest of that information, so the demand forecast for next week is 25 units. That's where this would go. And we have plans to make 10 next week, so that's where that would go, which is revealing that this is actually what the question is asking, is then by the end of the next week, how much would you have? To answer this question, really what you need is inventory logic. Inventory logic. The ending inventory for some certain period equals the beginning inventory plus any production that period minus, I'm going to write demand, but basically any use or any shipments. This is just a general relationship that we always talk about. At the end of a certain period, like next week, what do you wind up with? It's what you started with, beginning inventory, plus anything that you made, right? Minus anything that was used. So I need to fill this in to answer the question. The beginning inventory is right there, 62. The production is 10. The forecasted demand was 25. I put that in my calculator. And I get that the result is 47. As a result, you will wind up with 47 at the end of next week. So that's the answer to that question. The next question is actually referring to the same situation because it says Maynard Associates has 62 units of inventory on hand right now. That's the same. The demand forecast for next week is 25 units. Okay, yeah, that's the same. And Maynard plans to produce 10 additional units. That's the same. So the question's got to be different. It is. It's asking what will be the average inventory of this product next week. Well, wait a minute, we just answered an inventory question up here, but that was concerning ending inventory. Average inventory equals beginning inventory plus ending inventory divided by 2. Okay, so this is just a relationship that we kind of need to remember. Why is it called average inventory? What are you averaging? You're averaging the beginning and the ending inventory in a certain period. So that's why you add the two of them and you divide by 2. Okay, so for this particular problem, we have to ask ourselves, for this next week, what's the beginning inventory? Oh, the beginning inventory we would be starting that week is the 62. And the ending inventory is what we just figured out in the problem before. That's 47. So there's the two numbers that we need. 62 plus 47 divided by 2. What's their average? I get 54.5. That's the average inventory for next week.